Hemi is going to hold an iron in there. HemeGLOBIN, that's a popular one. But it's going to be the middle of the ring is what we're focusing on here. Big, big molecule. So let's just start in the middle. Iron. That's why your blood is red. Fe. So in the middle of this is held by nitrogens. What's nitrogen? Just a triangle. So 4 triangles in there. And we're doing this on the fly. Once you do it once, you can find out that 2 of these are actually closer. These are 5-membered rings around it, so these are easier than our benzenes, right? So don't get too worried about that. Let's just draw our diamonds in here. We'll even connect them. Diamond. 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 Connect it. So let's just draw the 5 around it first. Make it, this is the home base kind. Now see, when we got these bigger molecules, we can draw our diamonds right up next to each other. Or you can draw them with lines, however you feel comfortable. This is your way of doing it. And see, it's just simple diamonds. We'll worry about the bonds later. Home plate is 5. It's home plate. 4 home plates around there. Now off this puppy here is going to be a diamond. Just 1 diamond in there. What it gets is a double bond. So I should have drawn that different. That double bond to a single. And this nitrogen gets a double bond. Over here in between is a diamond. And we see off this nitrogen. Is this where the double bond's coming from? The nitrogen. Nope, it comes off the carbon. So just double bond it. 1, 2. It's going to have a single to that. Come along here, just draw the diamond in, worry about the bonds later. So we see this nitrogen coming off has a single bond with a double bond here. We see this coming off here has a single diamond, double bond there. 1, 2. Getting a little intimidated. We can color them in if you want. No, you're going strong? Okay, we see this nitrogen over here gets a double bond on it. So see, we did the 3s. Now we did our home bases too. You know what? As complicated as this ring structure looks, we just did the hardest part. So we see the bottoms of these guys get double bonds. Double bonds. These get double bonds on the side. So let's see, that should actually go there. This will go there. We kind of messed that up, didn't we? Make that one there. And we come across. Now they're not playing over again, are they? Okay, let's come off here as a methyl. Coming down here goes to a diamond, to a diamond, to a carboxylic acid. Draw the oxygens in there. No biggie, right? Double O, O. We look off up here on this ring, we got a methyl. got, wow, this is looking kind of cool. Here's a carbon with a double bond that's hydrated. So let's start drawing some dots in here, build our confidence up. Pretty big molecule going on here, isn't it? So we got 2 dots there. We got 1 dot there. This is a methyl with 3 dots. Coming over here is a methyl. Coming over here is carboxylate. Hydrated, 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 hydrated. Let's color some of those in. Carbon, 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 carbon. Double bonded up there. Pretty cool, huh? We got carbon, carbon. What's going on this guy? That's part of the ring there. So he's got 1, 2, 3, 4 bonds on that. Where's he going here? 1 to the methyl. Ah, see, there's a double bond in there. So we didn't draw that right, but there's 2 bonds in there. So see, like I said, we're doing this on the fly. This is hanging off with 1H there. So that's a double bond. Darken that in a lot, I guess. That's got 4. 1, 2, 3, 4. That one's done. Carbon here on the corner. Got 1, 2, 3. Colored it in, but I knew I was going to draw a dot there. So out here, that's going to get a dot. And go along all our corners here. Those carbons in the middle, even though they got a double bond on one of them, to one way or the other, it's going to have an H on it. So that's that part. Now we see some side groups over here, but we can handle those now. We're not worried. This is just a methyl. Look at that. CH3. This carbon is going to have, like it did up here, double bond. So diamond, diamond, double bond. Let's color those in while we got them here. There's a methyl. 1, 2, 3. 1, 1, 2. So you're starting to get a feel how when you're going along in a carbon chain, if it's on the end, it's usually going to have more of the proton hydrogens on there. So there's 2 hydrogens on that carbon. The one in the middle only has 1. There's a methyl. Color in the methyl's got the 3 on there. These guys got 4 bonds, 4 bonds, 4 bonds, 4 bonds. So we're done on there. Come around the clubhouse turn here. 1, 2, 3, 4 bonds on that. 1, 2, 3, 4 bonds on that. Come down the bottom. Double bond, single bond. But there's something hanging off the end of there. We've got 3 carbons coming off there. So there's 1, 2, 3 diamonds. Now there's got to be at least a single bond in there somewhere. That's going to be a carboxylic acid on the side, but who cares? Just big O, OH. I look over here, all that's coming off this is a methyl. We can do that real easy. Diamond, dot, dot, dot. These guys are hydrated in there. So let's go through now and do some more coloring. We've got our double bond here, 4 bonds. 1, 2, 3, 4 bonds. 1, 2, 3, 4 bonds. 1, 2, 3, 4 bonds. Come down here, 1, 2, 3, 4. 4. 4. Sounds like we're playing golf. 4. There's 4. 4. Connect the diamonds. So now we look in the middle of this. What we're going to see is that the nitrogen on the triangle here is going to be like dot, 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 dot through there. But it's going to be an actual bond this way. So we can color these in. This is the best way to draw